I think I'm going to go ahead and get started. And wow, is this so cool, seeing all these people who have come to my talk. Thank you so much. In the back, can you hear me clearly? Excellent. Thank you, technician. All right, my name is Justin Daniel, and I'm a senior software engineer with G2. I have many of my colleagues and teammates in the front here with me. And I will be presenting a custom design pattern for building dynamic ActiveRecord queries. Thank you so much for being here. All right, just note, I did build a demonstration repo with you with the help of fellow engineer John Polhill. The GitHub link is on the slide there, as well as the QR code for it. In this talk, I will be doing both PowerPoint presentation slides to summarize main points, and we'll also be working in the code editor and console to really digging in how this query pattern works. So my agenda for today, the big picture, why are composable queries so important? We'll compare different tools for composing queries, including raw SQL, ActiveRecord, and arrow tables. We'll then go over your own domain-specific language and introduce the query builder and visitor pattern that we've made at G2. How to use the builder pattern. Finally, I'll have time for questions and answers. I have one big goal here, and that's by the end of this presentation, I want you inspired to use this builder pattern. I want to not merely get you to have some understanding of it, but I want to convince you that this is a tool you want to try out. And I think our demonstration repo really gives you everything you need to get started with this. So let's start with the big picture here. Being a big data company is challenging. Serving all of your customers' needs, it can feel like pushing a big boulder up a hill. In particular, 3 challenges I'll highlight. We need to surface our data in many different systems, live web pages, CSV downloads, email notifications, third-party partnerships, such as in Salesforce, for example. We need to surface our data in a lot of systems. It needs to be filterable and customizable. Our users want data their way. They want to include just the fields they want. They want to filter out many irrelevant signals. We need to do this while maintaining fast, agile innovations. All right, so some acceptance criteria for our queries. Well, hard-coded queries are out of the question. They need to be composable. They need to be maintainable. Engineers need to actually be able to work with them. And they must remain performant even as we build higher layers of abstraction on top of SQL. So we need to build composable queries. And I really like the metaphor of Legos here. I'm a big Lego fan, have been since a kid. I just love the idea of having building blocks and being able to turn it into whatever you need. So our queries should be modular and shaped from smaller, interchangeable parts. They need to respond to logic and conditionals to attain desired output. And they need to return desired fields that might vary by the filters that users select. And composable queries can get messy quite easily. I'm sure many developers in this room have experience struggling with this. So what I'm going to show you is an old design pattern we used. This is legacy code, which involves SQL concatenation. And there were more than 230 lines of code in this file. These were served by many different private methods and a dozen or so helper files. The problem here, by the way, is not SQL injection. We guarded against that in other parts of the code. The problem is it's so easy to lose the plot here. I mean, you can follow that, yes, this is a SQL query. It has its different clauses, select, joins, whereby, groups, etc. but it doesn't really tell a story, and it's hard to work with, and it's hard to discover common parts of domain logic. So I made the decision to push our team to do a different design pattern here to compose queries. So I'm going to give you a sneak peek of what we were able to achieve here. And what you can achieve by using the builder pattern is you can once again go back to object-oriented programming when composing your queries. Here's our little sneak peek. You'll find this in the repo I referenced, and we'll dive deeper into it. For right now, though, I just want you to notice two things. One, we're back to using named classes in our query, which give you hints and discoverability for what the different clauses ultimately will be. The other thing I'd like you to notice is there's no conditional branches burdening this code. You are free to tell a story in your query class. As we'll see, the conditional branches come downstream. All right. Before we get to that, though, I want to convince you that this is potentially the right tool for your application. So let's compare different tools you might use for composing queries. So first, there's always raw SQL concatenation, and this still does have its practitioners and defenders. It has some advantages. When used correctly, it is the most performant, of course. You can't get any more performant by building an abstraction layer above it. It can do anything your database management system can do. And you have less of a dependency footprint. You know, you're not tied to your ORM, though you are tied to the database management system since SQL can vary a bit between those. All right, the downsides, your readability will really suffer. It's less maintainable, it's less composable and reusable. It's not as familiar to most Rails developers, and you get less linter help. All right, so how about just vanilla ActiveRecord, no libraries or higher level abstractions with it? Advantages, quite composable. It's more readable than SQL. After all, you're back to Ruby on Rails. And it's capable of most complex queries. It has its downsides. Big one, it doesn't handle conditional branching well by itself. And you may need to fall back to writing raw SQL at times. You do have a dependency on your ORM. So our next tool, and many Rails practitioners lean on this, are arrow tables. Certainly have their advantages. They deal with conditional branches well as complex queries. You have a reduced dependency on your specific database management system or ORM. The downsides, though, you are dependent on the arrow library now, so you've changed to a different dependency. I find the relational algebra syntax difficult to read, and I think many Rails developers agree with me. I really just love object-oriented syntax better. Big one here, and the main reason why we chose our own builder pattern over arrow tables is that you can express multiple concerns in a single node and that higher level business logic. So we come now to our custom design pattern with ActiveRecord. It's highly composable, deals with conditional branches well, it's object-oriented, uses Ruby on Rails. No complex library is needed. Really, if you download, clone our repo, you'll see how the pattern works, and you can adapt it in your own application. No tool is perfect. There are a couple downsides to consider. You have an additional learning curve. You need to be proficient with ActiveRecord as well as the builder pattern. And of course, you will have that dependency on ActiveRecord and Rails. Okay, so we're now going to really get into the nitty-gritty of the query builder and visitor design pattern. Just a note from here on, I call it the builder pattern. 6 words is just too long-winded, and I don't want to introduce yet another acronym, so we will call it the builder pattern. This is a higher abstraction that sits on top of ActiveRecord, Abstraction is what I love best about being a software engineer. I love designing this sort of thing so I can tell a story that appeals to humans and not just machine code. And here's where we will transition into our code editor, and I'm going to show you exactly how this works. So I need to give you just a bit of context on how we designed this repo. We needed to give it some minimum schema in order to demonstrate the point here. This is really just modeled off of a tabletop role-playing game character builder. For those who aren't familiar with tabletop role-playing games, that's not a big deal. What you need to know here is in our database schema, we have a central table called characters. So picture you're a dungeon master or somebody else with an interest in characters, and you want to be able to search among hundreds of thousands of character records. Our characters have a lot of associations. They're associated with campaigns, players, spells, feats, a whole list here. All right, so we need to be able to query from the characters table. And this is an example of one of our query classes, the index query. So there's really three main concern objects here for our query builder pattern. And that's query classes, builders, and nodes. So this here is a query class. This is your actual public interface that'll return an ActiveRecord relation. What we see here, it just has private methods that are implementation specific. It gets its public interface from its base class. Our base class has one public method that is call, so wherever in your application you need to run a query, you will send it the call message. And it does two things. It does apply, and it tells the builder to build. We have two main parameters here. We have the builder that's injected as a dependency, and we have filters. And the filters are really just a hash of different user inputs. Whatever user is calling this query will specify fields or filters they want. For instance, they might only want characters with certain spells. Okay, so the implementation of the call method will depend on the child class. So let's go back to our specific child class here. The apply method does a couple things here. First, it applies the joins that it needs, and it will only apply those joins to tables that it will need based on the filters. And it will add nodes to our builder. The initial state will simply be characters, so we're building an ActiveRecord query concerning characters. So we next need to know about nodes and builders. And I'm going to show you nodes first, because you're probably wondering, where is the conditional logic of this? And the answer is it's in the nodes. So we're going to take a look at one of those. We have one of our simpler nodes here. It spells level in. So this is going to produce a clause for the spells table where level are in levels. It takes a parameter of levels. Now where the conditional logic comes in is whether or not this node is valid. That's going to depend on the filters passed. The filters may or may not have levels present. If they're not present, this node will just be eliminated. We use inheritance again to give a common public interface. So all these different nodes will have an accept and a valid method. The accept method at its simplest will simply be a merging of different ActiveRecord clauses. So that's a node. Now let's consider our builder. Our builder is initialized with an empty array of nodes. Sorry, struggling to zoom in there. And it has two public methods. It has an add method and a build method. The query class will call add to give all the nodes the builder might need. And when all the nodes have been added, we'll call the build method. The build method contains our central algorithm, and that's a reducer. We're going to accumulate state of active record query converted from nodes. The builder doesn't directly direct that, though. It delegates to the nodes using the visitor pattern. That's why the block of code we pass to reduce is visit. To just see a little demonstration of how this works then, let's go into our console. Let's actually put a breakpoint in. All right, so we're inside our query class. Let's see here. Thank you for that. Is that better? Appreciate it. Okay, we start with some state here in the query class. It has its builder, it has its initial state. The builder is just initialized with the character table here, but it has no nodes. We're going to add that. So after applying a join, our builder now has an inner join node added to it. And we're going to add our other nodes here. And when we call builder.build, that's when our actual query will be constructed. And there we go. It filtered out all the irrelevant nodes that we just don't need. All right, so I hope that was a useful introduction to how this works. Bear with me while I try and get back to my presentation. This works a little differently than when you're not on a projector. There we go. All right, so let's sum up what we've learned so far. There's really some keys to understanding our builder pattern. It's object-oriented. It has 3 interacting objects, the queries, the builders, and the nodes. And the central algorithm uses reduce. I'm going to pause for a drink here. I like this diagram. It illustrates how the different objects work together. We'll go left to right. We have our query class. It takes in filters that will customize our query. Dependency injection of the builder. One public method, the call method. Calls 2 methods on the builder, add and build. Our builder itself keeps a state of nodes in an array and an initial state that it is given from the query class. When the builder is told to build, that's when it will loop over the nodes and it will visit each node. First, it's going to ask the node, hey, are you valid based on the state we passed in? The node knows if it should be added or not. If the node is valid, then the accept method will be called, and typically this will involve merging active record clauses. The node will produce a clause, and ultimately the builder then will return an active record relation to our query class. All right, and the central algorithm that this uses is the reduce method. Thanks for bearing with me here. We will go back to our code editor. And let's just take a closer look at the reduce method here. Let's go to our builder. Let's take a look at the base implementation. And we have our reduce method. Again, standard Ruby library reduce, you call it on an enumerable or an array. You simply combine different elements in an array using whatever code block you want. For instance, you could add different integers in an array. one example of reduce. Our implementation is customizable from the base class. So it takes in a block. You have a state and node as parameters. You visit each node. And let's see what our default builder does then. Let's make sure we zoom in here. Okay. So our custom reduce method, first it's going to loop over all the nodes and ask it, okay, are you valid? If the node is not valid, it's just going to be eliminated and won't be built as part of our query. For those nodes that are valid, we call reduce with our initial state and our block, and then visit each node. And we'll sum this up again in summary slides here. The big idea is that the reduce pattern both accumulates nodes and eliminates unnecessary ones. Essentially, we're just executing ActiveRecord query.merge over and over again. Now, we could do a naive implementation of this using conditional branches. We could have two queries. We could then merge if the names are present. This would really burden us with a lot of conditional logic, though, and it would be hard to do things such as nest different nodes. So the above is pretty tedious, it's brittle, it's not easy to follow for large queries. Ultimately, we're inspired to come up with a better idea, and that's the reduce method. You give the builder the nodes and let the nodes eliminate themselves. I really love metaphors. The metaphor I like here is a sculptor. You give the sculptor a medium, they will subtract out what's not needed, and what they want from the medium, such as a beautiful statue, will come through. Same idea with our reduce pattern. Summary slide. Builder builds through reduce and visiting of nodes. Code block is delegated to the node's own method. I'm going to pause for a second. I think one of the biggest advantages of this pattern is how it deals with the nesting of nodes and more complex queries. Excuse me. I love another metaphor, Russian nesting dolls. So a node can contain other nodes here. There are many use cases for this. You have your or, and, where clauses, higher domain logic, common table expressions, and subqueries. There are many cases when you would have to do nesting of nodes to get the query you want. And I think our pattern handles it pretty gracefully. So let's take a look at that. All right, we will go back to our query class here. I will show you one of the nested nodes. Let's comment that back out. We have our legendary node here. Now the story behind this is we have some higher business logic here. Perhaps our dungeon masters who are sorting through characters want to know legendary characters. And a legendary character will have several different attributes, different columns in their table, such as experience level and buff stats. So let's take a look at this. So our node here, it's initialized with a filter, and it has its own sub-builder. This is really our main insight. Our clause method is actually delegated then to the builder. Our builder will have child nodes added to it, and it will build, it'll build our clause out. So our and filters here, we have two concerns from the characters table. And let's just take a look at how that looks in console. Did I? Yep, I added the pry. Good. All right, so we're inside our nested node, the legendary node here. Let's see what happens when we add some nodes to the builder. All right, so now we have a nesting of nodes. All right, and we have a beautiful constructed query that can be merged into our larger query. So we want characters that have an experience greater than 10,000 and one other stat that's greater than or equal to 18. Oh, pardon me. It's a little clunky switching between the console and the slideshow. All right, let's summarize. With the nesting of nodes, we're delegating to its own builder. One of the nice nested nodes we constructed was a where's operator that can take child nodes inside of an and or an or clause. Our nested nodes will delegate their valid and clause methods to the builder. Finally, I'm going to sum up how you would use our query builder pattern. We just have 4 principles of best practice here. First, encapsulate your public interface of your query in a class. You want the query encapsulated in a query object class that has an appropriate scope. You don't want your query to be a monolith that tries to do everything, but it also shouldn't be too granular. Rule of thumb I like to do is 1 query class per API endpoint. There we have our index query we've been over, and I really like just the brevity of it and how it reads. I really hope that's been inspiring to you. You want to make it modular. You want to compose it of name classes that represent nodes. So again, we're returning to object-oriented programming where we have name classes that make them discoverable and understandable. The nodes can be general or tied to a specific table. Here are the different AND filters we used inside of our index query. Finally, you want to delegate to your builders and nodes. So you want to move the bulk of your logic outside of the query class. The node classes should have a valid method that will determine if the builder adds them to the ActiveRecord relation, and an accept method that will merge them into the ActiveRecord relation. Nice example here. This is from a different table, campaigns. You might have filters for the user to look for different start dates of a campaign. And this node will determine if it's valid or not if one of those filters are present. If it is, it'll introduce the where clause. All right. Finally, you want to make a builder that uses the visitor pattern. So a builder abstraction should be separate from your query class. Your query class will read descriptively as a story told in the node classes it contains. Your builder class will use the visitor pattern, visiting each node to extract its clause. And we saw that with our default builder here and the reduce algorithm it uses. All right, wrapping up. Abstraction frees our code to tell a story, and I hope this has come through in my presentation. We started with, in our legacy file, SQL concatenation, and we finally have hit upon a pattern where we can go back to using name classes and tell a story with the right abstraction. Our job as software engineers, after all, is to choose the best abstraction to use to make beautiful, maintainable code. Finally, just a shout out from my company, G2. We are growing and we are hiring. So please do consider giving us a look. A few acknowledgments here. Our builder pattern was made by 3 engineers, myself, John Polhill, and Evgeny Karpov. Really appreciate all the feedback I've been given on this presentation to help make it better. And G2 leadership, thank you for making it possible for us to spend the time developing this pattern, the funding to deliver it to you, the audience at Rails Conference. With that, I have time for questions and answers. Thank you so much. Absolutely. So the question was the GitHub URL. Let's go back to my slide here that has the QR code with it. G2 crowd/query builders. Yes? We did. And one of the reasons why we built our own pattern, first, we didn't want a dependency on anything else. And what we did, we actually looked online to see if anybody has used that same pattern, and to our knowledge, they have not. So really, we love owning this for ourselves. So the question was, why did I pass all the nodes to the builder rather than just selecting the nodes I wanted? So the answer to your question is, our logic needs to live somewhere that determines whether or not the node will be added. What we've done is we've moved that logic downstream to the nodes themselves, in particular with the valid method, as you recall. And the reason why, that really frees our code to tell a story. Instead of burdening our query class with all sorts of if conditionals, we put that in the nodes themselves. Did that answer your question? Wonderful. Yes? How do we keep them from building new query patterns is the question. I think they just like the builder pattern, honestly, is the answer. You got to give them something that they like more than the alternatives, right? If they find a better alternative, though, I'm not going to be able to keep them from using it, and nor should I. Yeah, that's a good question. So the question is, when do you know to build a new query class rather than a different nested node? I'm thinking here, often when you're writing specs, if it just seems like you have this explosion of branches and it just becomes too complicated, I get the sense of, okay, it's time to split this out into something different. That's probably the best answer I can give you, though there's many other factors, surely. Oh, that's true. I shouldn't say like there's no performance difference. Any abstraction you have on top of SQL execution is going to have some, some performance trade-off. Yeah, I hope I made that clear. How would it work? So the question is, how would it work for CTEs with the builder pattern we've used? Offhand, I don't have like a description I can verbalize, but I have built a query using this pattern that uses a CTE. Yeah, please reach out to me. I'll see if I can be more specific. So the specs I write for the query class, you can write specs for the nodes themselves. So really testing philosophy, I don't think there's a big difference. You're going to have some integration tests and some unit tests. Oh, let's think here. So the question was, what roadblocks did we run into when learning and building this pattern? I do know that us 3 engineers, myself, John Polhill, and Evgeny Karpov, spent a lot of time experimenting before we hit on this solution. So it's relatively simple, the reduced pattern I showed you, but we had to go through a lot of iterations to get there. I'd say our big roadblock was just trial and error and getting something that was both complex enough where the abstraction could be hidden away, and also performant and extendable while still being readable. It took a lot of trial and error. Thank you for all the questions, by the way. This is outstanding. I'm really glad for the interest in this. Any other hands I missed that are up? Any other questions? Yes, you can change subqueries, certainly. Or are you talking an entire query class? Yeah, I think so. I can't think of an example where we've done that offhand, but I don't see why not. Okay, I think we're at time. Thank you so much, everyone.